Nice. That
Yeah,
was a close game, man.
it was a terrific game. In fact,
It
it's
was.
been one of the best seasons ever for Denver.
Oh, for sure.
I,
Yeah.
I screwed up and missed watching like 4 or 5 of the games because my DVR wasn't working right. And they were
Gotcha.
unbelievably close. And then all
For
the games I
sure.
watched were close. So,
Yeah, for sure.
very important game, too.
Yeah, definitely. Now we have number 1 seed. Kansas City
Yeah,
has number 5.
yeah, I know. Terrific.
Nice. Because the Patriots lost today, which is awesome.
I know it. Amazing.
Yeah.
So,
Hopefully we don't choke in the playoffs like we
well,
always do. But
and, they kind of had the ideal ending. They had Peyton Manning come back in and do well.
exactly. He did pretty well,
What
yeah.
they want. They're not going to win a Super Bowl with Brent Osweiler. They're going to win a Super Bowl with Peyton Manning.
Uh-huh.
I mean,
Definitely.
if
Yeah.
they're going to win one.
Exactly. I think it'd be a great year for the Broncos to go because it's probably Peyton Manning's last season.
Yeah, yeah.
You know,
No, it was a terrific last game. Just terrific.
for sure. Yeah,
That was exciting. And
definitely.
timing was actually just perfect.
Awesome.
All
Cool.
right.
All right.
Yeah, no, I was glad to see you schedule some more sessions, which means
Uh-huh.
we can get further into this geometry curriculum that I like.
Definitely, yeah.
I want to finish it before you get back into geometry class, where I would like to.
Sure. Sure, yeah.
May not finish it, but we'll get quite a ways. So,
Perfect.
okay, so let's see. We're into quadrilaterals and other polygons, which should be
Okay.
right up your alley, because that's exactly what you've been doing for the last month.
Yeah, definitely.
All right, how about this problem number 2?
Okay. Let's see here. I think you would do. So you have to have it. You just add them all up to 360 and then divide it by, or and then subtract 360 by that number, right?
Well, you're on the right track. Do you have a calculator in front of you?
I do, yeah.
Okay. Remember the secret for geometry.
Okay.
The secret for geometry is not to try to solve for x in one step.
Okay.
It's to solve for everything else that you can solve for. What's this angle right here?
That angle it 180 minus 70 or 360 minus 75, right?
Okay, no, 180. Remember,
180.
the magic number is 180. It's not 360.
Okay. That one's 105. 105.
And what's this angle right there?
Um, 180 minus 155.
No, minus 60.
Oh, 18. Oh, yeah, my bad. My bad. That's 120.
Now the magic number is 360 because we're dealing with a quadrilateral.
Okay.
So how do we solve for x here?
You do 120 plus 50.
Go ahead and do it on your calculator. Do all of those.
Okay. I got 85.
Okay, does that make sense? The sum. Oh, you're talking about 85 for.
For X, yeah.
Good.
Altogether, I got 275.
Okay, good.
Yeah. Okay.
Yeah, and that's a very typical geometry problem. Is where you can never solve for what they're asking for in one step, but if you solve for what you can solve for, you'll see that you can solve for it.
Cool.
It's good, yeah. Okay,
Awesome.
number 4.
Okay. What is the ratio of the area DEC to the area of square ABCD in the figure above? Would it be 1/3?
No. Although I know why you said that.
Because it's like in three parts.
Well, no, I know that I have taught you that when you go to a point that it's 1/3. But that's only if it's in 3 dimensions. In other words,
Okay.
you're going from a right cylinder to a cone, that's 1/3.
Okay.
But this is in 2 dimensions. This is only area. This is not volume.
Okay.
Okay? So,
Uh-huh.
the fact that this is a square doesn't really matter, but we'll call that side S and that side S.
Okay.
What is the area of the square?
Base times height.
Which is?
So it would be S squared.
What is the area of the triangle?
It would be side squared divided by 2.
What is the ratio of the area of the triangle to the area of the square?
Just S over 1, wouldn't it be?
Well, what's your intuition tell you? I want you to start using your intuition.
Okay.
It could either be a half, a third, a fourth. What is it going to be?
A half.
There you go.
Okay.
Okay? Now, the way we actually get that is to take that and divide it by that. So, if I do that, I got S squared over 2 divided by S squared. Well, now it's not immediately clear what that answer is. So I have to apply I'm dividing by a fraction. I'm going to reciprocate it. Excuse me, this is S squared. And multiply, so it's really S squared over 2 times 1 over S squared. The S squareds cancel, and you get 1/2.
Okay, that makes sense.
That's how you get it. But, in other words, some of geometry is just intuition. I don't really mean intuition, I mean common sense.
Yeah.
Look at this picture. There's no way that triangle is twice as big as the area of the square. So we can rule that one out. So it's either 1/2, 1/3, or 1/4. Well, what does it look like? It looks like 1/2, right?
Yeah, for sure.
Okay. Well, there's a bigger principle here.
Yeah.
Doesn't have to be a square. What's the area of that rectangle?
Area is equal to BH. Just, yeah.
Now, if I make a triangle inside of that, what's the area of the triangle?
BH over 2.
What's the relationship between the area of the triangle and the area of the rectangle?
The area of the rectangle, or the area
of the triangle versus rectangle.
Okay, so the area of the triangle is half of the area of the rectangle.
Exactly.
Okay.
Okay. Cool. And that is regardless of how I draw that triangle. I can draw that triangle like that. It's still half.
Okay.
I can draw that triangle like that. Then it's clearly half. Cool. But it turns out that no matter how I draw that triangle, it has to be half the area of the rectangle. And that's a good thing to know, because when you're going to memorize areas of triangles, you know that it's not base times height, it's 1/2 of that.
Okay. Yeah, that makes sense.
Yeah.
Okay. Cool. Aspen, no. No, no, no. Come here, girl. Come here. Good girl. Hi, good girl. It's alright.
All right.
All right.
Again, we're in quadrilaterals and polygons.
Okay.
1, 2, 3, 4, 5, 6, 7, 8. This is an 8-sided polygon.
Okay.
First of all, is it concave or convex?
Convex.
Good.
Cool.
That little trick that I mentioned probably worked, huh?
It did, yeah.
Yeah, if
For
you
sure.
want to go into a concave, you want to make sure you can see every single spot in that cave.
Mm-hmm.
Whereas if I were to go into this thing right there, I would not be able to see if there was a bear over there.
No, for sure.
But if there's a bear over there and I'm entering a concave polygon, I'd be able to see it instantly.
Exactly.
Okay.
Cool.
Let's see, we don't want to do that one. We want to do number 6. In other words, we want to do evens only.
Okay. Cool.
Go ahead and read the directions to yourself.
Okay.
I prefer that students read them to themselves rather than out loud, because when you take your ACT test, you're not going to read it out loud. You're going to read it to yourself.
Yeah, for sure. Okay. So the figure,
Let's go.
wouldn't it be 20?
Sentence by sentence.
Okay. So the figure above is made up of 5 squares of equal area, with a total area of 20.
What's the area of each square?
The area of each square is 5.
No, hold on.
Okay.
What is it? You got 5 squares, you got a total area of 20.
So it would be, so each square is 4, yeah.
Okay. What are the dimensions of each square?
The dimensions are 5. Well,
That dimension right there. If the area is 4, what does the x have to be?
the next has to be 16. Oh, if the area is 4, then it'd have to be 2. Yeah, my bad.
That's all right. You got there. Even if it took you a minute, that's better than not getting.
Yeah.
So that's 2. They're all squares.
Mm-hmm.
What's the perimeter going to be? Because that's what they're asking about. They're not asking about area. They're asking about perimeter.
So the perimeter would be 22. Well, 2, 4, 6, 8, 10. Yeah, 22.
Add them all up. First of all, we have 3 of them. And we're not adding that, we're not adding that, we're not adding that, we're not adding that. So what do those 3 add to?
6.
How about those 3?
6.
Those 3?
6, and then 6.
4 times 6?
24. Okay.
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 But this is a very, very typical geometry problem. In the fact that in this case, you have to figure out a couple of things first. Not just one thing, but you have to figure out what the area of each square is, and then you have to figure out what the side length of each square is.
Yeah. Exactly.
So these are great problems. Well, hold on. I'm not sure I got all the problems on that page.
Okay.
Yeah, I did.
Cool.
So you're only scheduled for half an hour tonight. So let's do just one more problem.
Okay.
Number 8.
Alright, so in the figure above, AD is parallel to BC. What is the perimeter of the quadrilateral ABCD? AD to BC.
So the only side missing is that one.
Yeah. So could you set it up as like a proportion?
No, we're not dealing with similar figures here.
Yeah.
However, what you can do is break this thing up into a rectangle and a triangle.
Okay.
We know this is 250.
Yeah.
We know that's 40. We know that's 50. Let's draw a dotted line right there.
Oh, I see what you mean.
That's also 250.
Uh-huh.
Well, if that's 40, what's x?
So if that's 40, 90. Well, no.
Okay. There's one skill that I absolutely am going to insist that you get before we stop working, before you go back to school. Even if we have to do it every single time on every single question. And that's solving a right triangle.
Okay.
So in order to figure out x, we need to solve this right triangle.
Yeah.
There's two ways to do it, and I want you to know both of them.
Okay. Sure.
Do you know either one?
Well, 90, 180 minus the sum of those two angles.
Now, let's talk about the Pythagorean Theorem.
Oh, a squared plus b squared equals c squared.
There's a, there's b, there's c.
Okay. So it would be 40 squared plus b squared is equal to 50 squared.
Keep going.
Alright, and then it would be 160 plus b squared is equal to...
First of all, this is 1600.
Uh-huh.
When you
Oh,
square
my bad, yeah.
you square it and it has 1 0, it's going to have 2 zeros when you're done.
Okay, did I say 160?
Uh-huh.
Oh, my bad, yeah.
Squared equals, what's 50 squared?
2500.
Okay, next step.
And then now we could subtract 1600 from both sides.
B squared equals 900. Next step.
And then square 900. Find the square root of 900.
Right.
And that would be 30.
Okay.
Cool.
So x is 30.
Mm-hmm.
And notice that that is a 3, 4, 5 right triangle. If there's anything you want to be able to recognize in geometry, it is a 3, 4, 5 right triangle. Now, that's a 30, 40, 50, but it's either a 3, 4, 5 or a multiple of 3, 4, 5.
Okay.
This is a multiple of 10 of a 3, 4, 5. But what I'm saying is that had you recognized that as a 3, 4, 5 triangle, you wouldn't have had to do the math. You would have immediately known that that was 30.
Uh-huh. Yeah.
In other words, let's talk about that a little bit, because this is not one of the special triangles, but it really is. In other words, there's lots of special triangles in geometry. There's a 3, 4, 5. There's also a 30 degree, 60 degree right triangle.
Yeah, and then a 45, 45.
So these are your special triangles that you want to memorize. Okay? Yeah. And notice that they're significantly different. This, I don't know what the angles are.
Mm-hmm.
These
what kind of angles?
Here, I know what the angles are. What are the dimensions? Remember I told you I was going to ask you this every single time until you got it right. What's opposite?
Yeah.
What's opposite the 30-degree
The opposite of 30-degree angle is,
angle? I called
uh,
my unit special triangles.
yeah.
What does that
So
mean?
we find,
Why do I call it my unit?
well, we're trying to find R of L.
Because the side opposite the smallest angle is 1.
Is, yeah.
That gets
Okay.
started.
Yeah.
Okay?
And then the bottom is the square root of 3, right?
Good.
And then,
Hypotenuse is what?
uh, and then the hypotenuse is 2.
Very good. What's
Cool.
opposite the 45-degree angle in this one?
1.
What about this?
That's also 1, and then the square root of 2 is the hypotenuse.
Good. Very good.
Cool.
You get these two triangles down, and it's going to make geometry so much easier for you.
Cool.
Okay? And I'm serious, because so many questions, it's when you take your ACT test, it's not going to be about congruency.
No.
It's going to be about similarity.
Okay.
So they're always going to be giving you triangles that are similar to one of these three.
Okay.
Right? In other words, they may give you a 40, 50, 30, or 30, 40, 50 triangle, or they could give you a 6, 8, 10.
Mm-hmm.
That is the same as that with a scale factor of what? Or a linear factor of what?
With this 1/2.
Big to little. Always go big to little.
Big to little.
Despite,
Okay, so 2 to 1.
despite what Anzac says. I know he goes little to big, and I hate it.
Yeah.
It's so much easier to go big to little.
Yeah.
What is
So it would be 2 to 1.
Yeah.
Uh-huh.
The reason it's easier to go big to little is because you're dealing with numbers greater than 1 instead of little.
Yeah, whole numbers. Yeah.
When you deal with numbers less than 1 and you have to square it or cube it,
It's hard.
confusing. It's
Yeah.
not really, I mean, if you're doing it on a calculator, it's not really harder, it's just more confusing. Whereas if you go big to little, you're always dealing with a number greater than 1, and then you have to square it or cube it. It gets bigger like you expect it to, and it's not as confusing.
Okay.
Okay?
Cool.
So remember these 3, and I'm going to add a 4th one.
Okay.
And this one is the second smallest Pythagorean triangle. This one's the smallest. There's none smaller than that. There's no such thing as a 1, 2, 3.
No.
2, 3, 4. Okay? 3, 4, 5 is the smallest perfect Pythagorean triangle. And by that I mean where all 3 sides are integers.
Okay.
Okay? The next one is 5, 12, 13.
Okay.
Okay? And again, you want to recognize this, but it may not come as a 5, 12, 13. It may come as a 10, 24, 26.
And you have to find the ratio.
Well, notice that that's the same. That's a similar triangle as this. It's got the same 5, 12, 13 ratio.
Yeah.
Now, and quite honestly, they don't ever give you that one. You will have to recognize this one, or you don't have to, because you could always use Pythagorean's theorem to solve it, but it's so much helpful. When you take the ACT test, they're going to give you like 10 triangles to deal with. 8 of them are going to be either this one or this one.
Gotcha. Okay.
So if you recognize these, it's going to save you a ton of math. You don't have to solve the right triangle. In other words, if I tell you you have a 3, 4 triangle like that, then you know that has to be 5. Or if I tell you you have a 5, 13 where the hypotenuse is 13, then you know that has to be 12.
Gotcha.
So it saves you like 30 seconds in computation ability.
Mm-hmm.
Now, notice the big difference between these two triangles and these two triangles. I
Mm-hmm.
don't know the angles up here.
No.
I have no idea. It's not important. The only thing we're looking for are the sides and a hypotenuse in this ratio, and if they are, it's a right triangle. And that's what's important.
Okay.
Okay? So everything
Uh-huh.
on my page you want to memorize. Lock it in.
Sure. Yeah, definitely.
But I'm glad to see that you've memorized this thing here.
Yeah, definitely.
Now, we got about 2 minutes. When did we start? We started about 15 minutes late, maybe 10. Okay.
Yeah.
I
I
don't.
think it was like 5:43 is when we
solve,
started.
we solve this. Once we
Yeah.
solved for AD, then finding the perimeter is trivial.
Yeah, exactly.
Let's go back to this picture here.
Okay.
What I'm going to do is give you similar triangles.
Okay.
Tell me what X is.
All right. So we know that R of L is 2 to 1.
Okay?
So we would do 2 to 1 times let's see here. The 2 over 1 times the square root of 3.
No. What's the side opposite 30 degrees? That's what you want to look for.
1.
Okay. So it's 2 to
Okay.
1 times.
Times 1.
Exactly.
Okay.
So this is.
I was looking at it wrong, yeah.
Well, I oriented it this way on purpose. I didn't want you
Yeah.
I didn't want you to have to depend on its orientation to solve it. In
No.
other words, the way you solve it when it's not oriented properly is you look for the side that's opposite the 30-degree angle.
Okay.
Okay?
Yeah.
And so what's the other side? What's this side here?
And then that side is square root of 3. Or just, yeah. I was looking at the bottom. Alright.
Is it going to be the same as this side?
No.
What is it going to be?
So we know that it's 2 to 1 times 1, so it'd just be 2.
Just 2?
2y. Or no, 2 square root of 3. My bad.
There you go. There
Yeah.
you go. In other words, we know this side has to be twice what that side is.
Yeah. Yeah.
Okay?
Okay. Awesome.
All right.
Cool.
All right. That's a good place to stop. I'm glad to see you're making good progress on this.
Yeah, for sure.
By the time we're done, you're going to have these down so you will never, ever forget them. Or
Perfect.
forget how to solve a right triangle. If I gave you sides of 7 and 5, I want to make sure you can come up with that quickly.
Okay.
Okay?
Yeah.
So
Okay.
we'll keep working on some of that. But
Perfect.
yeah, no, I definitely see progress being made here.
Awesome.
Dylan, I will talk to you at 10:30 in the morning.
That sounds good, yeah.
All right, bye-bye.
Alright, bye-bye.